In 1998, the fastest SUV on the planet was a Jeep Grand Cherokee. It had a 5.9-liter V8 under the hood, made 245 horsepower, and hit 60 in 6.8 seconds. That was the absolute peak of SUV performance back then. Fast forward to right now, and Jeep just put a 4-cylinder engine in the Grand Cherokee that makes 324 horsepower and hits 60 even faster. Oh, and it uses Formula One technology that was only found in a $200,000 Maserati supercar until this year. Nobody saw this coming. To understand why car people are losing their minds over this engine, you need to know what is sitting inside it. Because from the outside, a 2.0-liter turbocharged 4-cylinder sounds boring. Every car company makes one. Toyota has one, BMW has one, Honda has one, but none of them have what Jeep just put in theirs. It is called Turbulent Jet Ignition, TJI, and until 2020, this technology only existed in 2 places on Earth: Formula One race cars, where teams spend $150 million a year on engine development, and the Maserati MC20 supercar. That Maserati costs over $200,000 and makes 621 horsepower from a twin-turbo V6 with a pre-chamber ignition system. Maserati spent years developing it. They patented it. They bragged about being the first production car in history to use F1 combustion technology. And then Jeep took that same core idea and stuffed it into a family SUV that starts at $46,135. The Maserati Nettuno V6 makes 210 horsepower per liter. The Jeep Hurricane 4 makes 162 horsepower per liter. That is lower, and intentionally so. Jeep prioritized efficiency and long-term durability over peak output. The Maserati is a hand-built supercar engine designed to scream at 8,000 revolutions per minute. The Jeep is a mass-market engine designed to tow 6,200 pounds and last hundreds of thousands of miles on regular gas. Same technology, completely different goals. But wait, what even is a pre-chamber, and why does it matter? Think of a normal engine. You have a cylinder, a piston going up and down, and a single spark plug that lights the fuel. The flame starts at one point and slowly crawls across the entire combustion chamber. By the time it reaches the far edges, the first part is already done burning. The burn is uneven, it is slow, and that slowness limits how much power you can safely make. Now picture Hurricane 4. On top of each cylinder sits a tiny copper cup about the size of your thumbnail. Jeep calls it the pre-chamber. It has 9 holes drilled into it. 8 holes arranged in a circle, each one 1 millimeter wide. 1 hole in the center, 0.5 millimeter wide. During the compression stroke, some of the air-fuel mixture gets squeezed up into this little cup. A spark plug inside the cup lights it, and that small explosion shoots 9 jets of flame down through those tiny holes, ripping into the main cylinder from every direction at once. Instead of 1 flame front, you get 9 flame fronts. The fuel burns 3 to 4 times faster. The burn is way more complete, and that is what changes everything. Now, why are some of those holes different sizes? The 8 outer holes are about 1 millimeter wide. The center hole is only 0.5 millimeter, and the reason is simple. The center hole points straight down at the piston. If that jet was as strong as the outer ones, over time the energy would literally melt a hole through the piston crown. So Jeep made it smaller to protect the piston. The outer holes need more energy because their jets have to travel further to reach the edges of the combustion chamber. Bigger holes, more energy, wider reach. And if you are thinking those tiny holes would clog up with carbon over time, Jeep thought of that too. Every compression stroke pushes fresh fuel and air back up through the holes, and the cleaning properties of the fuel help scrub them. But the real answer is simpler. The temperatures inside the pre-chamber get so extreme that any carbon deposits just burn off instantly. Jeep says clogging has not been a problem in any of their testing. See, the biggest enemy of a turbocharged engine is knock. Knock happens when the fuel ignites too early or in the wrong spot. It can crack pistons. It can destroy head gaskets. And it is the main reason most turbo engines use low compression ratios, usually around 9:1 or 10:1. Low compression is safer, but it kills efficiency. Because TJI burns the mixture so fast and so evenly, knocks almost never happen. That let Jeep run a 12:1 compression ratio on a turbocharged engine. For context, that is higher than some naturally aspirated engines that have 0 boost pressure at all. Higher compression means more work extracted from every single combustion event. More work means more power and better fuel economy from the exact same amount of gas. And that is not even the wildest part. This engine also has 2 spark plugs per cylinder, one inside the pre-chamber, one in the main combustion chamber, and they do not just fire at the same time. Depending on the driving situation, the engine picks a completely different ignition strategy. At low power, like idling at a red light, the main chamber plug fires first. At that point, there is not much air and fuel being pushed into the pre-chamber, so the conventional plug takes the lead. As load increases and more mixture fills the pre-chamber, the system flips. The pre-chamber plug leads, and the 9 turbulent jets become the primary ignition source. And at full throttle, at peak boost, only the pre-chamber plug fires. The main plug shuts off completely. Why? Because cylinder pressures at max power are so extreme that firing the main plug would actually damage it over time. The pre-chamber handles everything on its own. Also, quick mention, I made a Jeep longevity guide based on everything I've learned. If you're trying to keep yours in top shape, it's linked down below. And that brings us to the turbocharger. Because this is not just some regular turbo, it is a variable geometry turbo. Inside the exhaust side of the turbo housing, there are adjustable vanes that can open or close based on what the engine needs. Quick history lesson. Porsche was the first company to put a variable geometry turbo on a gasoline production car. That was 2006 on the 911 Turbo. 20 years later, Jeep is the company bringing that tech to a mainstream 4-cylinder. Nobody had that on their 2026 bingo card either. At low RPM, the vanes close down tight. That speeds up the exhaust gas, spins the turbo faster, and builds boost almost instantly. 90% of the engine's 332 pound-feet of peak torque shows up between 2,600 and 5,600 revolutions per minute. That is a huge usable power band for a 2.0-liter engine pushing around a 5,000-pound SUV. At high RPM, the vanes open wide. Now the turbo flows like a much larger unit without choking the engine. Peak horsepower hits 324 at 6,000 revolutions per minute, and the engine redlines at 6,500. The maximum boost this turbo can push? 35 pounds per square inch. That is 2.4 bars. The BMW M3 and M4 use twin turbos and only hit about 25 pounds per square inch. This single Jeep turbo pushes 10 more pounds per square inch than a BMW M car. Think about that for a second. But 35 pounds per square inch is not the everyday number. That is the ceiling. At sea level on a cool day, the engine makes full power at a much lower boost. The 35 pounds per square inch only kicks in at high altitude or extreme heat, when thin air means less oxygen per breath. The turbo compensates by cramming in more pressurized air. So whether you are driving in Miami at sea level or crossing a mountain pass in Colorado at 10,000 feet, you get the same 332 pound-feet of torque. Always. The engine adjusts for you. And because the vanes can control boost so precisely, this engine does not even need a wastegate during normal driving. There is one on there, but it only opens during cold start to route exhaust straight to the catalytic converter for faster warm-up. Under normal conditions, the vanes handle everything. Now add in the fuel system. 2 injectors per cylinder. Port injection and direct injection working together. The engine controller decides which system to use and how much of each, depending on what you are doing with the gas pedal. Cold start? Both fire at once to heat up the catalytic converter fast and reduce emissions. Idle? Port injection only, because it runs quieter and kills that annoying ticking sound that direct injection engines are known for. You know that metallic rattle you hear when a turbo BMW or Audi is idling next to you? That is the direct injection pump. At idle, the Hurricane 4 shuts it down completely and just runs on port injection. The engine sounds smooth and refined, which matters when you are sitting in a $60,000 Summit trim at a red light. Typical driving with moderate throttle? Both systems work together in varying ratios depending on demand. Full power? Direct injection dominates, spraying fuel at 5,076 pounds per square inch. That is 350 bars. A fire hose runs at about 150 pounds per square inch. This fuel system sprays at over 33 times that pressure. That insane pressure atomizes the fuel into a mist so fine that it cools the incoming air charge, further reducing the risk of knock and letting the engine make even more power safely. On top of all that, the engine runs the Miller cycle. It closes the intake valves early, before the piston finishes its downward stroke. This forces the throttle plate open wider to get the same amount of air in, which reduces pumping losses. Less energy wasted just breathing means more energy going to the wheels. Combined with TJI and the 12:1 compression ratio, this gives the Hurricane 4 a thermal efficiency of roughly 40.5% at 100 kilowatts. Most gasoline engines sit between 30 and 36%. Formula One engines reach about 50%, but they get rebuilt every few races. Getting 40.5% from a mass production engine that runs on 87-octane pump gas is wild. The numbers tell the whole story. Compared to the old 2.0-liter turbo in the Jeep Wrangler, this engine makes 20% more power while burning 10% less fuel. Compared to the 3.6-liter Pentastar V6, it makes 31 more horsepower, 72 more pound-feet of torque, and gets better gas mileage, 21 city, 27 highway, 23 combined. The Grand Cherokee with this engine hit 60 in 6.2 seconds. The old V6 took about 7.2 seconds. That is a full second faster from an engine with almost half the displacement. And the power density on this thing is absurd. 162 horsepower per liter of displacement. The Honda Civic Type R makes about 157 horsepower per liter. The Jeep beats it. A Jeep Grand Cherokee is making more power per liter than a Honda Type R. Read that again. The construction of this engine is just as serious as the tech inside it. The block is die-cast aluminum with a deep skirt design. Cylinder bore walls are 24% thicker than the old Jeep 2.0-liter. Instead of iron cylinder liners, Jeep sprays a plasma transfer wire arc coating onto the bore walls. PTWA melts a steel alloy wire at 2,300 degrees Celsius and blasts microscopic particles onto the surface. The result is a coating 10 times more wear-resistant than iron. Better heat transfer too, which helps keep temps manageable at 35 psi of boost. The crankshaft gets larger main bearings and connecting rod bearings to handle the higher cylinder pressures. A structural windage tray and balance shaft sit low in the block. A viscous crankshaft damper smooths out vibrations. An electric water pump and variable displacement oil pump cut parasitic losses. Jeep engineer Ashish Dubey, who led the Hurricane 4 program, said the bottom end was designed to handle maximum boost for tens of years. Not a couple of warranty periods, tens of years. Every component was built to survive 35 pounds per square inch from day one, not retrofitted after the fact. The stiff crankshaft, the oversized bearings, the 24% thicker bore walls, none of it is aftermarket-grade Band-Aid engineering. And the only part this engine shares with any other motor in the Stellantis lineup is the oil filter. Everything else, from block to turbo to pre-chamber, was designed from a clean sheet. Dubey said his team learned hard lessons from the Hurricane Inline 6 program and applied every single one to this four-cylinder. Towing capacity stays at 6,200 pounds, same as the V6. Driving range stretches past 529 miles on a single tank. The engine is assembled in Dundee, Michigan, with the block and PTWA coating done in Kokomo, Indiana. For some perspective on just how far engine technology has come, think about this. In 1998, the Jeep Grand Cherokee 5.9 Limited was the fastest SUV on the planet. It had a 5.9-liter V8 making 245 horsepower and 345 pound-feet of torque. 0 to 60 in 6.8 seconds. That was considered insane for an SUV. The early 2000s Grand Cherokee ran a 4.7-liter V8 that made 235 horsepower. The 1990s Cherokee XJ had a 4.0-liter inline 6 making 190 horsepower. This Hurricane 4 is 2.0 liters, half the size of that old 6, less than half the size of that V8, and it makes 324 horsepower, nearly 90 more than the V8, 134 more than the inline 6, and it does 0 to 60 in 6.2 seconds, faster than that 5.9 Limited that once held the crown. From an engine that weighs less, burns less fuel, and has less than a third of the displacement. That is not a small improvement. That is a different universe of engineering. The 2026 Grand Cherokee with the Hurricane 4 starts at $46,135. The Summit trim pushes past $60,000. J.D. Power gives the 2026 Grand Cherokee a quality rating of 81 out of 100, and RepairPal estimates average annual maintenance at $666. Not bad for a vehicle packing F1 combustion technology. The first car company to bring pre-chamber ignition to a mass-market SUV is not BMW, not Mercedes, not Toyota. It is a Jeep. And whether this engine holds up over 200,000 miles or turns into a reliability question mark, one thing is certain. The engineering inside this 2.0-liter four-cylinder is the most advanced combustion technology ever put into a vehicle at this price point. And that changes the game for every other automaker trying to squeeze more from less. This engine is seriously impressive. But the real question is, will it actually last? Drop a comment below. Would you trust this over the old V6 or not? And if you want your Jeep to hit crazy mileage without issues, my full longevity guide is linked below. Subscribe if you want more deep dives like this. See you next time.